Assalamu alaikum everyone. So lecture number 7, and we will be talking about more review questions and answers, and today we will finish our review exercise from chapter 1 from the book Wireless Communication and Networks, written by William Stalling. So these are the bullets which we will be talking about regarding the review questions and answers. First of all, we will talk about different types of media, and we will take one question, review question from guided and unguided media. Then we will have microwave transmission, and after that we will be talking about direct broadcast satellite DBS, and we will take another review question from this topic, and then we will be having multiplexing, and we will take more than one questions from multiplexing, right? So let's start. So as we talked about in details in our previous lectures regarding guided and unguided media, right? So here we have a review question that we have to differentiate between guided and unguided media. So at the bottom of this slide, you can see that we have a hierarchy diagram, right? So at the top or at the root, we have the transmission media, and then we have categorized transmission media into two different classes. First one is guided, and we call it wired, and the other one is unguided, and we name it wireless. So if we talk into more details regarding the guided media, so we have a twisted pair, and we have coaxial cable, and finally optical fiber or fiber optics cable. So this is the physical media, or we call it guided media, right? So one of the key difference between those different media we have also discussed those differences in detail. So let me talk about some of the main points. First, in twisted pair we have two different categories, two different classes: unshielded twisted pair and shielded twisted pair, UTP and STP. And then we have coaxial cable. So we can bundle them into one class because they use the same signaling technique in order to represent data, right? So the signaling used, we represent data by using electrical pulses, and we know that whenever we have electrons moving along a guided media or along a conductor, so there is a coupling between electric field and magnetic field. So we can say that the data is traveling in the form of electromagnetic radiations over here, right? So actually the representation is in the form of electrical pulses, but we know that when electron move, so there is a coupling of electric and magnetic field. So this is the one class which is having certain characteristics. They are made up from metal. We have shielding, somewhere we don't have shielding, somewhere we have cladding and insulation, and so on and so forth. So there are different characteristics and different points that differentiate them from one another. So this is a one class of guided media. Then we have optical fiber. So as opposed to the electrical pulses, here we use light in order to represent the data. So as the movement of those photons, the data is traversed from one point to another point, and we normally prefer optical fiber when we have to transmit data at longer distances from one city to another city. So this is another class of guided media. Then comes the unguided media, and other category of transmission media. So we normally call it wireless, and you know that we have air, atmosphere, water. So these are different examples. So again here we transmit data in the form of electromagnetic energy. And here one of the main difference, as the name mentions, that in case of guided media, the signals are being guided along the path of the medium, right? So if we have a cable, for example, twisted pair, so signals will be guided along the path of that cable where it is lying down. On the other side, in case of unguided media, signals are not being guided along the media, right? So this is not automatic. You have to force in order to have a directional communication. We need to use certain antennas in order to have a focused communication. So here we have certain definitions, few definitions. As you know that we define transmission media as a physical path between sender and receiver. And if we talk about computers and telecommunication devices, right, so they have to represent data. So in order to do that, they must use some sort of signaling technique. And if they have to transmit that data, first data representation by using certain signaling technique. If they have to transmit that data, so they transmit that data by using some form of electromagnetic energy. And we also talked about the electromagnetic spectrum. So if we talk about the electromagnetic spectrum, so we have radio waves, infrared waves, and then visible area. There is a visible area, the light which our human eye can see, and then we have ultraviolet light and X-rays and gamma rays. Right. So here we have classification of transmission media by using some other characteristics. So here you can see that we have mentioned that the guided media is a conductor, such as a wire or a fiber that is made up of a glass. So in case of conductor, we have a copper wire or metal wire, but in case of fiber optics, we have a glass wire or plastic wire. And that media is used in order to move the signal from one direction to another direction. Or you can say that the signal traverses from one point to another point by using this conducted media, conducted or guided media, because we can only say conducted in case of metallic wires. Then we have wireless. So in case of wireless, we use radio waves of different frequencies, as we have talked about the electromagnetic spectrum in more details, right? And we do not need wire or cable in order to transmit the data. So now we have enough material and enough points in order to answer our review questions, right? So the review question was, we have to differentiate between guided and unguided media, right? So now we have many characteristics of those different media, and we are in a position to answer our review question. So with guided media, the electromagnetic waves are guided along the physical path of the medium, whereas in case of unguided media, the data is being transmitted by using electromagnetic waves, and the medium is free space or air, or it can also be water. But one of the key difference here is that we do not guide them. We can only transmit electromagnetic waves. We cannot guide them. So this is the key difference and our answer. So let's have another review question from another topic, microwave transmission. So the review question is, what are the advantages and disadvantages of microwave transmission? First of all, we should know that where microwave lies if we talk about the electromagnetic spectrum. So here let me explain the spectrum, right, so that we can answer our review question in a good way. So you can see that we have a wavelength that is mentioned in meters, and then we have frequency that is in hertz, and here we have the visible light. So it means this portion of the spectrum is visible to human eye, right? So you can see the wavelength is decreasing and the frequency is increasing if we move from left to right, right? If we move from right to left, so you can see that the wavelength is increasing and the frequency is decreasing. So this is, you can say, they are inversely correlated over here, wavelength and frequency, right? So and you can also see from the waves over here, right? So here you can see that the vibrations are being completed very fastly if we move here at the edge of this figure on our right hand side, right? So here again you can see X-rays, they have high frequency and shorter wavelength. Ultraviolet have more frequency than visible light but less frequency than X-rays, and they have shorter wavelength than visible light and they have longer wavelength than X-rays. So here we have the microwave, right, 10 raised to power minus 2, and it remains there till we have infrared, that is starting from 10 raised to power minus 5 wavelength. Okay, let's talk about microwave transmission and its characteristics so that we can answer our review question. So as we have seen over the electromagnetic spectrum that microwave transmission, it covers a major portion of the electromagnetic spectrum, and it uses frequencies that start from 2 gigahertz and it ends up till 40 gigahertz. So as we know, we already studied that higher the frequencies, so potentially we will be having higher bandwidth. So as a result, there is higher data rate, right? So here you can see we have band, the bandwidth, potential bandwidth, and the data rate that can be achieved. So 2 gigahertz and the potential bandwidth is 7 megahertz, and we can achieve a data rate of 12 megabits per second. 6 gigahertz, we have potential bandwidth of 30 megahertz and the data rate is on the higher side, 90 megabits per second. So 11 band is 11 gigahertz, bandwidth is 40 megahertz, and we can achieve the data rate again on the higher side, 135 megabits per second. So this is 18, and the effective bandwidth is 220 megahertz, and we can achieve a data rate of 274. So here you can see that if we have a higher frequencies, we can achieve higher data rate that can be transmitted by using the microwave transmission. So here we have some of the examples we can have directional point-to-point focus beam employing high frequencies. So you can see that we have two antennas. They are aligned with each other, and their beams are directed from one point to another point. So the frequencies are very, very high, and we have point-to-point communication. So here on this, in the omnidirectional, the waves are propagated in all directions, right? And you can see that this antenna is radiating in all directions, and all the antennas which are lying here, they will be receiving it. Okay, so if we have an antenna over here, that will be also receiving this communication. And similarly, if we have an antenna over here, so it will be also receiving the, so omnidirectional in all directions. So we can also have the scenario in a cell phone. For example, we have an antenna and the radiations are being transmitted in all directions. So if you have a cell phone over here and over here, and that are within the cell range, so they will be receiving the communication. So here we have terrestrial microwave. So you can see that we have microwave flying between infrared and broadcast radio, right? So as mentioned, broadcast radio and infrared, and microwave is in between. And you can see the frequency range 2 to 40 gigahertz, and we can have point-to-point and multi-point. And then again, if we talk about the microwave, we have two different types, terrestrial and satellite. So here, if we talk about the alignment of the antenna, so we have to take care the curvature of the earth, contour of the earth, so that our antennas should be aligned in such a way that we can have point-to-point communication. So that's what we have discussed in one of our previous lecture. So satellite microwave, so you can see here we have a satellite and is used for link ground stations. So here we have one ground station and here we have another ground station. So in order to link this ground station to this ground station, right? So maybe if they are lying apart, that they cannot transmit data directly, so we have the very broad vision or very broad range if we use the satellite. So you can see this one is transmitting data to this satellite, and this satellite is broadcasting and then repeating or sending the data to the ground station on the other side. So we can use a number of frequency bands, and here we have different transponders that are being used in order to support different frequency bands. So there's another very key difference, that in case of satellite microwave, we have two different frequencies for transmission and reception. So we have uplink. We use a certain or particular frequency for uplink, and then we use another frequency in order to avoid interference for the downlink. So you can see this is sort of uplink and this is the downlink. So here we have same scenario. Here we have the transmission from ground station to the satellite, and then satellite is broadcasting to these two different ground stations. So here broadcast, and here we have point to point. If I want to show, so this ground station is actually communicating with this ground station. So this is point to point. So here we have shown satellite, microwave satellite point to point link. Earth or ground station is transmitting to the satellite, and then satellite is transmitting to another ground station on the Earth. So point to point, and here we have the broadcast. So this is the transmitter for this satellite, right? So it's you can say the uplink, using uplink in order to transmit data to the satellite, and satellite is again broadcasting this data or repeating this data so that it can be received by those ground stations. So multiple receivers. So this is the broadcast. So now we have enough material and enough points so that we can answer our review question. What are the major advantages and disadvantages of microwave? So one of the key advantage that if we are talking about point to point, so we can achieve higher data rate, and the less attenuation is observed if we compare this with the twisted pair or coaxial cable. But one of the disadvantage is that this communication is affected by the weather, for example rainfall, and if we have communication over 10 gigahertz, so there can be much more problem. So we can also have line of sight, right? The antennas should be aligned. So that's why there can be interference from some other microwave transmissions. If we have very intense communication at some points at the ground. So these are some of other advantages and disadvantages. So the advantages of microwave includes we don't need any cable. So as I mentioned, it's a satellite microwave communication or terrestrial microwave communication, so we don't need any cable. And we have multiple channels that are available and higher bandwidth. So the disadvantages include we need line of sight communication, and this line of sight can be obstructed by obstacle. For example, if there are some aeroplanes or some other metallic objects or buildings, so this can be disrupted. And then we have another disadvantage, that the signal is absorbed by the atmosphere. So it means microwave transmission or either satellite or terrestrial, they are being affected by the atmospheric conditions. And there is another disadvantage, that we have to build towers in order to achieve the line of sight communication. So they are much expensive to build. So these are the advantages and disadvantages of microwave communication. So here we have another review question, but the topic is direct broadcast satellite DBS. So first of all, we will be talking about DBS. So DBS is actually a satellite television system where the subscribers or the end users, they are actually receiving signals from the satellites, and one of the key feature of those satellites that they are geostationary. They are also moving alongside the movement of the Earth, or we have aligned those satellites in such a way that we will not be losing the point of contact at the Earth. So signals are broadcast digitally, and the frequencies that are being used, they are microwave frequencies. And this technology is descendant of direct-to-home satellite services. So what we need, so if I'm a DBS subscriber, so I need a dish antenna. So you might have seen dish antennas that are aligned at a certain angle at the rooftop of a home, and the diameter of this antenna is 3 feet, that is 60 to 90 centimeter. And we need a conventional TV set and a satellite receiver, right? And from the dish antenna to the satellite receiver, we need a coaxial cable. So the dish or the dish antenna, it intercepts microwave signals directly from the satellite, and then those signals are being received by the satellite receiver, and then after the conversion we can see the communication, or we can see the we can use the services as a TV. So here we have the scenario. So you can see that we have antenna. So as mentioned that we have to use two different frequencies, one for downlink and the one for uplink. So this is the rooftop of some of a home subscriber, and here we have the actual data that has to be broadcasted by using this satellite. So this is the uplink. So for uplink we will be using one frequency, and for downlink we will be using another frequency. So this is the dish antenna that is being receiving this communication from DBS, direct broadcast satellite, and this antenna is connected to this satellite receiver by using the coaxial cable, and then this coaxial receiver will be converting those signals so that it can be displayed on this TV. So one of the most recent application of satellite technology to TV distribution is direct broadcast satellite, in where satellite is transmitting video signals directly to the home user, and you know that the cost is very low, so that's why it's nowadays very popular among users. So as mentioned that in case of satellite communication we are actually using two different frequencies, one for uplink and one for downlink. So what is the reason behind doing that? So we have a review question over here that why we are using two different frequencies for uplink and downlink. So first of all, we should know that what an uplink is and what is downlink mean regarding the satellite communication or regarding the transmission. So if we talk about the satellite communication, so the uplink mean that the data or signal is being transmitted from Earth to the satellite, right? So you noted that the direction is from ground station or from Earth to the satellite, and this is called the uplink. If we talk about the downlink, So in case of point-to-point, we can say that the satellite has to repeat the same communication, same data, or transmit the same data over to the ground station at another point. So let me draw over here. For example, we have a satellite link over here, right? So here we have the satellite, actual satellite, and this is another ground station. So from here, GS ground station 1, and then we have GS 2 ground station 2. So this is the direction is from ground station to satellite. So you can say that this is uplink, and then this satellite has to transmit data over here, so to the ground station 2, and this is the downlink, right? So now we have a better understanding of uplink and downlink, and this is the use case when we have point-to-point, from this point at the ground station to this point at another ground station, so point-to-point. So there can be a use case when we have a broadcast scenario. So uplink will be transmitting to the satellite, and satellite is transmitting back to the ground stations, more than one ground station, and it is actually broadcasting. So this is the uplink, right? So you can see the direction, this is the dish, and there we have the downlink, right? So now we are in a position to answer our review question. So the review question is why we are using different frequencies for uplink and downlink if we talk about the satellite communication. So the reason is that we want to avoid the interference. So that's why we are using one frequency for uplink and another frequency for the downlink. For example, in a typical use case, satellite use frequency bandwidth range of 5.925 to 6.425 gigahertz from Earth to satellite. So this is the uplink, and then you can see the difference. A range of frequency of 3.7 to 4.2 gigahertz from satellite to Earth, downlink. And uplink frequency is normally higher than the downlink frequency. So we are leaving this point at this moment for our future discussion or lectures. So here we have another review question, that is, we have to differentiate between microwave and radio frequencies. So first of all, we should know that where those different frequency ranges, they are actually lying over the electromagnetic spectrum. So if you can see that we have microwave, and here we have the radio. Let me encircle them. So here we have radio, and here we have microwave. So as we all know that if we move from left to right, the frequency or energy will be increasing, and if we move from right to left, the wavelength will be increasing. So here you can see we have a lesser wavelength, and this wave is carrying lower wavelength, and so on and so forth. So they are very close to each other, or you can say adjacent to each other over the electromagnetic spectrum. So here we have some of the advantages and disadvantages of microwave communication, microwave frequencies. So as mentioned that it is discovered, actually microwave frequencies are discovered by a German scientist, and we are actually using in a lot of different applications that includes wireless and Bluetooth devices. We are also using microwave communication regarding GPS, global positioning system, and the home appliances utilization includes microwave ovens. And one of the disadvantages of microwave communication is that it can damage the human body, different organs. For example, they are very dangerous for eye. And then we have radio waves, and it also includes some of very key utilizations like UHF, VHF, and then we are also using RFIDs, and they actually use radio frequencies in order to communication data, right? And so one of the key difference between radio and microwave is that in case of radio frequencies, the communication is omnidirectional, okay, and in case of microwave we have focused communication. And you can see the different uses of packet radio, teletext services, then we have cellular communication. So these are different uses of those radio frequencies. So here we have another review question. So we need to mention differences between broadcast radio and microwave. So as we know that in case of broadcast we have omnidirectional communication, and if we are talking about the broadcast, we don't need dish-shaped antenna, and the antenna don't have to be mounted and aligned. So sending and receiving antenna don't have to be mounted and aligned. So this is one of the key difference between but as we know that in case of microwave it is omnidirectional, and the antenna should be aligned and the communication should be focused. So this is one of the key difference between broadcast radio and microwave. So now multiplexing. So the review question is why multiplexing is cost effective. So first we need to discuss multiplexing. So you can see that we have many input lines, and you can see that those input lines, they are within a city and they are terminating into the central exchange, and from central exchange of one city is connected to the central exchange to another city, and then we have sub exchanges within that city. So between one city, here we have city A, let me name, and here we have city B, and those lines, they are actually in. So from one city to another city we have only one link that can be an optical fiber, so that we can have high data rates. So we have to multiplex over here. So all the data has to be multiplexed, and then it after multiplexing, this data is being transmitted over here. So if this has to be connected here, so virtually there should be a communication between this point and then this point, and then this point and this point. So it means this communication should be synchronized. So each input line giving a certain time slot. So here we have some of the reasons that why we are using multiplexing. So as mentioned, that cost per kilobit per second of transmission is decreasing with an increase in the data rate. Cost of transmission and receiving equipment declines with increased data rate. So these are the advantages or reasons for multiplexing. And most individual data communicating devices require relatively modest data rate support. So we have two different multiplexing techniques which we will be talking about. First one is FDM, that is frequency division multiplexing, and then we have time division multiplexing. So in FDM, we take advantage of the fact that the bandwidth of the medium exceeds the required bandwidth of the given signal. So we will slice the frequency into different sub-frequencies in order to take advantage of this bandwidth. Then we have time division multiplexing, that achievable bit rate of the medium exceeds the required data rate of the digital signal. So we have time slot here. Each input line is given a certain time slot. So this fiber optics has very high data rate, so each input line is given a particular time slot over here. So this is TDM. So here we have shown FDM. So you can see this is the frequency axis, and here we have the time axis, and we have slice or division of different frequency into different frequency channels. So this is the whole frequency that is available for a particular medium, and then we have divided that frequencies into sub-frequencies: F1, F2, F3, F4, F5, F6. So we have 6 channels that can be exploited in order to have separate communication by using F1, F2, F3, F4, F5 and F6. So we can have an example of voice signals, that the spectrum for voice communication lie between 300 to 3400 Hertz. So frequency of 400 kilohertz is enough in order to carry the voice signals. So here each signal requires a certain bandwidth centered on its carrier frequency, and we normally call this carrier frequency as the channel. So here we have division in the time slot. So you can see that each channel is allocated a certain time slot. So we can take the advantage of huge data rate that is actually supported by the medium in case of TDM. Preassigned and fixed. So it means there should be a very good synchronization between sender and the receiver in case of TDM. So here we have shown some of the graphical examples of TDM and FDM. So here we have TDM, and this is a sort of TDM frame. So first A, then B, then C, and D. So you can see A, B, C, and D. And again here we have demultiplexing. A should go to here, B should go here, and C and D. So this is sending, and this is the receiving side, sender side. And so here we have FDM, amplitude modulation with carrier frequency F1. So modulated signal. So we have digitized data. So again amplitude modulation with carrier frequency F2. So we have we are using another carrier of frequency f2, centered f2. So this is the modulator signal, and then after the modulation, signals are added or combined and they are being transmitted over here. And on the receiver side, we will be performing demodulation. Okay. So this is one of the key reasons that we can use the maximum frequency and the data rate that is actually supported by the medium, because higher data rate, the more cost effective the transmission facility is. Of course, if we have higher data rate, the communication facility will be much cost effective. So then we have another question from multiplexing, how the interference can be avoided by using FDM. So here we have shown that we have FDM and we have slices the frequencies into different sub-frequencies that are being centered at F1, F2, F3 and F4. So though we have not shown here the guard bands, so in order to avoid interference between F1 and F2, we have a guard band here, so that there should not be any interference in between. Guard bands, which are unused portion of the frequency spectrum. Although we will be losing some of the portion of the frequency, but this can be a trade-off. If we want to avoid interference, then we have to do that. So here we have another review question. So the question is, we have to explain synchronous time division multiplexing. So we have two different types of multiplexing regarding TDM. One is synchronous and other one is asynchronous. So we will be talking about synchronous TDM over here. So you can see that if we talk about the synchronous, so you can see we have, if I start from here, so this data has to green and green, so you can see the colors. And here we have yellow, this is very close to red, right, red, and here we have blue and blue, dark blue. So you can see that, so here the graphical interpretation, and here we have theoretical interpretation. So in case of synchronous TDM, the multiplexer interleaves bits from each signal and takes turn transmitting bits from each two of the signals in a round robin fashion. So it's a round robin fashion, first here, 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 and then again it will start from here, 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 here. Again demultiplexing is being exploited by using round robin, so, and this should be synchronized. So that's all for today's lecture, and that's almost finished our review question answer session regarding the first chapter of the book, textbook, which we are following. So today we have talked about guided media and unguided media, and we have taken a review question. So first we discussed what the main characteristics are there in the guided media and the unguided media, and then we have tried to answer the review question. Then we talked about microwave transmission, and we discussed some of the key points, features of microwave transmission, and then after doing that we try to solve the review question. And after that we talked about DBS, direct broadcast satellite, and we answered a review question that is related to the DBS And finally, we talked about multiplexing, and we also solved or answered some of the review questions that are from FDM and TDM and simple multiplexing. So that's all मेरी तरफ से. अल्लाह हाफ़िज़, अपना ख्याल रखिएगा. अस्सलाम वालेकुम.